Hello friends, welcome to next lecture in kinematics of machines. So in this video lecture, we shall see what is Kennedy's theorem and what is angular velocity ratio theorem. So both these theorems are based on the instantaneous centers. So we have already seen two videos in the previous lectures. One is about the instantaneous centers and second one is the equation to determine the number of instantaneous centers in a mechanism and the types of instantaneous centers. So you can refer both the videos which will appear on the top right corner as YouTube icon. So friends, before we begin with this video lecture, I request you to please subscribe to this YouTube channel. Click on the bell icon for the latest notification of lectures on this YouTube channel. Follow us on Twitter, Instagram and like our Facebook page, Mechanical Engineering Tutorials. So friends, let's begin with this video lecture. So first we shall see what is Kennedy's theorem. So Kennedy's theorem is also known as Arnold-Kennedy's theorem. So if it is Arnold-Kennedy's theorem or just asked Kennedy's theorem in the examination, it is one and the same. So we have the definition of this theorem, that is, according to this theorem, if three bodies have plane motions, their instantaneous centers lie in a straight line. So this we shall take up with an example. So here let us draw three bodies. So this is the first body which is fixed, then we have the second body and we have the third body. So let these three bodies 1, 2 and 3 have plane motions. So here the link 1 is fixed as shown in the figure. So the number of instantaneous centers can be determined using this equation, n is equal to n into n minus 1 divided by 2. So here we have number of links as 3. So small n can be substituted as 3 in this equation. So when we substitute, we get this n as 3. So we have the three instantaneous centers. One is I12, I13 and I23. So on the figure, I12 is located here and I13 is located on this point over here, that is between link 1 and link 3. I12 is between link 1 and link 2 and I23 is between link 2 and link 3. Let I23 be at point A as both the bodies 2 and body 3 join at that point. So here consider this point A first on body 2 only. So the direction of the velocity of this point A is indicated by this arrow mark and it is denoted as VA2, which is perpendicular to the line AI12, that is this dotted line here. Now we shall consider this point A on the body 3. So when it is considered on the body 3, the velocity of this point A will be indicated by this arrow and denoted by VA3. So this is perpendicular to AI13. So to represent the instantaneous centers I23, it is necessary that the directions of VA2 and VA3 be same for point A. So this is possible only when VA3 will be equal to VA2. So as you can see now here, this VA3 and VA2 will be equal only when we have this condition, that is they will be in a same line and VA3 will be equal to VA2. So it can be stated that VA2 will be equal to VA3 and the relative velocity will be 0 if the directions are same. So here if this direction is same, the relative velocity will be 0. So this will be possible only when this point A and this I23 will lie on this link 1. Thus we can say this I12, I23 and I13 will lie in the straight line, and that is what here the Kennedy's theorem states. If three bodies have plane motion, their instantaneous centers lie in a straight line. So thus here we have proved the Kennedy's theorem, also known as Arnold-Kennedy's theorem. Now we shall see the next one, angular velocity ratio theorem. So now we consider this case for the Arnold-Kennedy's theorem, that is the three instantaneous centers of these three bodies will lie in a straight line. Now suppose we want to measure VA3. So VA3 can be measured using the equation omega 3, that is the angular velocity of link 3 into I23 minus I13, or the distance between I23 to I13. So that distance is taken here. Now VA2 can be measured as angular velocity omega 2 of link 2 and the distance between I23 and I12. Okay, so here this is that distance. Now suppose we want to determine any of the angular velocity. Suppose in this case we know the angular velocity of link 3 and we need to determine the angular velocity of link 2. We know that VA3 will be equal to VA2. Thus we can say this equation, that is omega 3 by omega 2, will be equal to I23 I12 upon I23 I13. So thus, seeing this equation, we can say that the angular velocity ratio theorem is achieved. That is, the angular velocity ratio of the two links relative to the third link is inversely proportional to the distances of their common instantaneous centers from their respective centers of rotation. So here this will be inversely proportional to the distances of the instantaneous centers. So that is all about the angular velocity ratio theorem. So friends, that's all for today in this video lecture. So if you have understood the explanation about the Kennedy's theorem and angular velocity ratio theorem, please like and share this video with your friends. Please subscribe to this YouTube channel if you have not yet subscribed. Click the bell icon for the notifications and follow us on Twitter, Instagram as well as on Facebook. The links are in the description below. Thank you very much friends.